In today's video, we're going to have a look at actually putting expressions into the required form of the wave function by using the addition formula and comparing, and what we were doing in the last worksheet, solving a certain type of simultaneous equation. Remember, these are your addition formulae. Now what I'm going to do is I'm going to go through these four examples because we can ask, do we put it in that form, this form, this form, or this form? I've chosen these so it's going to be one in each quadrant, okay? Though mostly it'll be like the first one, which is a first quadrant one. The majority of questions set it in the first quadrant, but you do get ones in other quadrants, so you need to be able to find the phase angle. Okay, and the last one I've also thrown in the idea that we're going to have to do radians as well. Okay, let's make a start with this first question here. Okay, what we're going to start off by doing is we're going to look at this expression here, which is what we want to turn it into, and we're going to expand it. We're going to look at the cos x plus alpha bit. So, if we think of it, I'll just put the k on the outside. If I expand cos x plus alpha, remember it's going to be cos x cos alpha minus sin x sin alpha. That's using our addition formula. So we put that in. Cos x cos alpha minus sin x sin alpha. Now, with this, remember k and cos x and k and cos alpha and sin alpha, these are our constants. Okay, so I'm going to write it with the constant bit first when I multiply it out. Okay, so if we do that, that will give me k cos alpha cos x minus k sin alpha sin x. I've just written it again with the constants at the start. Then I'm going to have a look at what I've been asked to compare it to. Look, I've been asked to compare this to that. But look, that's the constant in front of cos x. That's the constant in front of cos x there, isn't it? Okay? And if we're looking at it, that is the constant in front of sin x. That is the constant in front of sin x there. So what we have here, and you'll recognize this from yesterday, is we've got that k cos alpha is equal to 2 and minus k sin alpha equals minus 3. Well, that's the same as writing k sin alpha equals 3. Yeah? Now, this is exactly what we were doing yesterday. Remember, we work out k by squaring and adding these two and taking the square root. So k is simply those two squared and added, which gives us root of 13. Okay, and then remember, if we do sine divided by cos, tan alpha equals k sine alpha divided by k cos alpha, which in this case is 3 over 2. But we know more than that. We also know that sine is positive, so sine is positive and cos is positive. Okay, so first of all, I'm going to work out the inverse tan of 3 over 2. Remember, we always work out the inverse tan of the positive bit. If I work that one out, Okay, it gives me 56 degrees. Now we know, remember our cast diagram? Draw it across here. All, sine, tan, cos. We know because sine is positive, it's got to be one of those two. And because cos is positive, it's got to be one of those two. And this is the place where both of those intersect. So here we are dealing with a first quadrant angle. So alpha will be 56 degrees. So we're asked to write it. So my last thing is I'd write that 2 cos x minus 3 sine x equals root 13, that's my k, cos of x plus 56 degrees. Okay, so that's the first example done. Remember, after the expanding and comparing, it's exactly what we were doing yesterday. Okay, this time we've got 3 cos x minus 4 sine x, and we want to put it into k cos x minus alpha form. Again, alpha between 0 and 360. Our first step is, again, what we're going to do is we're going to expand the cos x minus alpha. If you remember, cos, that'll give us cos x cos alpha plus sine x sine alpha. Remember, we now want to combine the constants. So remember, cos alpha and k and sine alpha are the constants. So if we put that at the start of each bit, what we're going to get is k cos alpha cos x plus k sine alpha sine x. As before, we can compare. So we know the bit in front of the cos x, which is a 3, must be the same as k cos alpha. And the bit in front of the sine x, which is minus 4, must be the same as k sine alpha. So we can write those two bits down. We therefore know k cos alpha equals 3 and k sine alpha equals minus 4. We're in the same position as we were again yesterday, solving that sort of equation. First of all, to find k, just square, add and square root those two. So we've got 3 squared plus minus 4 squared. And if you work that out, that gives you 5. So we know that k is 5. For the next bit, remember we want tan alpha, and tan alpha is going to be k sine alpha over k cos alpha. And that's going to give me minus 4 over 3. But we know more than just that the tan is negative. We know that the sine is negative, and we know that the cosine is positive. Okay, so when we're doing our cast diagram later on, remember all sine, tan, cos, we know for sine negative, it must be either third or fourth. But for cos positive, we know it's got to be first or fourth. So we're talking about a fourth quadrant angle here. But before we do that, we're just going to work out the first quadrant angle. So ignore the signs, just do inverse of 4 over 3. If I do that, that gives me 53 degrees to the nearest degree. But remember what we said? We said alpha had to be a fourth quadrant angle, so alpha is going to be 360 minus 53, which is what? 307 degrees. So now we can write it. We've got 3 cos x minus 4 sine x equals 5 cos x minus 307 degrees. Okay, and that would be that one done. What I've got to do with this one is I've got to put this into k sine x plus alpha form. So, what we've got to do first is expand sine of x plus alpha. So if I expand that, I'm going to have k sine x cos alpha plus cos x sine alpha. Again, putting the constant bits, which is alpha and k, to the front of each bit is going to give me k cos alpha sine x plus k sine alpha cos x. So this time, the bit in front of the cos x is k sine alpha, yeah? And the bit in front of the sine x is, so it's green, is k cos alpha, okay? If you're comparing it, look, the bit in front of the sine x is minus 7 and k cos alpha. The bit in front of the cos x is k sine alpha, and that's 2. So now, when we're writing it down, we've got that k cos alpha equals minus 7, and we've got that k sine alpha is equal to 2. And okay, again, we can see in this case, cos alpha is negative, so the cos here is negative, and the sine is positive. We'll bear that in mind when we come to it later on. Remember, first of all, let's work out k again. K is always just those two squared and added. If we work that out, it gives us what? 49 and 4, 53. Root 53. Then remember, we've got that tan alpha is equal to k sine alpha over k cos alpha. Okay, which k sine alpha is 2, k cos alpha is minus 7. But remember, more than that, the cos is negative, the sine is positive. Yeah? That sine is positive, cos is negative. So when we look at our cast diagram, okay, we can see that the sine is positive, yeah? So that's going to be those two for the sine. And we can see the cos is negative, so negative for cos has to be second or third. So we can see it's going to be in this one. We're going to be looking for a second quadrant angle in a minute. So we know at the end it's going to be 180 minus the angle we're just about to work out. Okay, so if we look at that, first of all, I'm going to do inverse tan of 2/7. Remember, ignore the negative to start off with. That gives me about 16 degrees. Okay, but we've said it's got to be second quadrant, so the angle we actually want is going to be 180 minus 16 degrees, which is 164 degrees. So our final answer here would be that 2 cos x minus 7 sine x equals root 53 sine of x plus 164 degrees. Okay? Okay, the last example we're going to have a look at is going to involve radians, but that's just one final step, which you'll see when we do it. Okay, in this last example, our final bit is our angle is going to be in radians. Remember, for radians, to go from degrees to radians, you multiply by pi over 180. So what I'm going to do is I'm going to solve this in degrees, and then I'll change to radians right at the end before writing my final answer. So same as before, we've got to expand sine x minus alpha. Remember, so that's going to be k sine x cos alpha minus cos x sine alpha. That's simply using your addition formula. Put the constant bits to the first. Remember, that's the k and the alpha. So k cos alpha sine x minus k sine alpha cos x. Then we're going to compare. That's the bit in front of the sine x, so that's the minus 3. And that is the bit in front of the cos x, so that would be the 5. So let's write those two down. So we've got k cos alpha equals minus 3. And we've got minus k sine alpha equals 5. But we really want to write that as k sine alpha equals minus 5. So they're both negative here. So let's work out k. Remember, we just square and add them. Be careful with your negative signs. I always stick them in brackets. If we work that out, it will give you a root of 34. Just squaring and adding them. Remember, again, tan alpha is going to be k sine alpha over k cos alpha, which is minus 5 over minus 3. Okay, now we know from this sine is negative and cosine is also negative. So if we look at our cast diagram, all sine, tan, cos, sine negative has to be one of those two because it's positive up there, and cos negative has to be one of those two. The only place it can be, therefore, is a third quadrant angle. So we're going to be looking at 180 plus, remember, for third quadrant. Right, but first of all, let's work out what our first quadrant angle is. So we keep it positive, 5 over 3. If I work that out, it gives me about 59 degrees. I'm talking about third quadrant here. So remember, alpha will be 180 plus that 59 degrees, which is 239 degrees. At this stage, I'm going to change it to radians. So, which is equal to 239 times pi over 180. If I work that out, it gives me 4.17 radians, which is what I was after, because it's 2 pi up there. So let's write it out again. You've got 5 cos x minus 3 sine x equals root of 34 times the sine of x minus 4.17 radians. Okay, that covers how you can put this sort of thing into the wave function. You should now be able to do the questions in today's exercise. In the next two videos, we're going to look at how we can use this to find a maximum or minimum, and how we can use this to help us solve trig equations.